Hi, Mr. Corsi here. In this question, we're told the number of customers who visited 6 different stalls one Saturday at a farmer's market. Here they are. Here there's 6 pieces of data. We're asked to calculate the mean of these 6 pieces of data and the standard deviation. So let's have a look at that. Now, we'll look at the standard deviation. Two different formula for that. I'm going to use the first formula as it's slightly easier, I think, to do the calculation, but either of these two formula could be used. So we'll lay this out first of all under the column X, X being any of these pieces of data. So X stands for the 120, the 126, the 125, the 131, the 130, and the last piece of data, 124. And let's add them up, because to find their mean we have to add them up and divide by the number of numbers, which is 6 in this case. So the total, you do this on the calculator, I'm just going to do this in my head, 4, 5, 10, 16, 3, 6, 9, 11, 13, 15, and then 756. You check that on your calculator. So to find the mean, which is X with a wee bar, there it is sitting there, the mean is defined as the total of your data divided by the number of pieces in that data, which is n. There's an n sitting in the formula there. So in this case we've added them up. There's 756 for the total, and we know there's 6 pieces of data. And again, calculator for this, but you'll find that's 126 for the mean. So let's proceed using this formula. The next thing we'll need to do is to look at x minus x bar. And this is called the deviation from the mean. What's the difference between each of these data points and the mean that we've calculated? So in the first case, 120 minus 126. 126 minus 126. 125 minus 126, 131 minus 126, 130 minus 126, finally 124 minus 126. So these are the deviations from the mean. However, this little squared here means that we square them as the next calculation. Negative 6 squared is 36. You notice every time we square a number we'll get a positive or 0 number. Never get a negative number in this column. 0 squared, 0. Negative 1 squared is positive 1. 5 squared is 25. 4 squared is 16. Negative 2 squared is 4. And we have a sigma there. Sigmas mean adding. So we need the total of these squared deviations from the mean. So that's our next calculation. Again, use your calculator to be sure you're getting the answer. So that's 20, 45, 70, 81 for that total. Now we've basically done all the calculations we need. We can dive into using this formula, which is the square root of the sum of these squared deviations from the mean, which we've calculated, over 1 less than the number of pieces of data that there are. So it's the square root of that 81 total that we've just got over 5. Remember, there were 6 pieces of data. N minus 1 will be 5. Again, calculator here, what I'm going to do is double top and bottom, get 162 over 10. If you divide 162 by 10, you get 16.2. So I know that I have to find the square root of 16.2. So let's find that, 16.2. In this calculator we do square root first, sorry, 16.2. That gives us 4.024, and so it goes on. Now I'm going to round this to 1 decimal place. There's no indication of how accurate that should be, but we've basically answered part A, where we have the mean, which is 126, and the standard deviation is 4.0. Chopping that 2 off just leaves that 0. 4.0. The accuracy is to 1 decimal place. So that's the answer to part A. So let's move on to part B of this question. And in this one we're told the mean number of customers that visited the 6 stalls on Sunday and also the standard deviation. And we're asked to make 2 valid comments comparing the number of customers on the Saturday and on the Sunday. So we did calculate 2 statistics. We calculated the mean, we calculated the standard deviation, so there'll be 1 statement involving the mean, 1 statement involving the standard deviation. So let's start with using the mean. And we know that on the Saturday we calculated the mean number of visitors to the stalls as 126, and they're now telling us that on the Sunday there was 117 as the average number of visitors. So basically the number of visitors was greater on the Saturday. So we can say that the average number, that's what this is all about, means the average number of visitors on Saturday was greater than on Sunday. So that's the first statement, using the mean. Let's now use the standard deviation information that we're given, and on the Saturday our calculation was that the standard deviation was 4.0. On the Sunday they're telling us the standard deviation was 6.2, which is a lot greater, well, a good bit greater than on the Saturday. Now that means that the number of visitors at these 6 stalls was more spread out around the mean than on the Saturday. So we can say that the number of visitors was less varied on the Saturday, or more varied on the Sunday, was less varied on Saturday than on Sunday. So that these 2 statements would be suitable for gaining the marks for this question. Average number of visitors on Saturday is greater than on Sunday. The number of visitors was less varied on the Saturday than on the Sunday. So that's Mr. Corsi signing out, and thanks for watching this video.